I think one reason we may want to consciously spur the development of a domestic fuels industry. A few years ago, around 2000, petroleum represented about 20% of our trade deficit. It's now up to 40%. It's rising very dramatically. I think there are a lot of economists that believe we're not going to get out of the economic slump that we're in until we can come up with a way to reduce our dependence on petroleum. And there are three ways we can do that. We can conserve our way out, and we should be doing everything we can to conserve and avoid the demand for energy. We can drill our way out, and there are people very aggressively saying we should drill in the Arctic, we should drill off the coast of California and Florida, or we can invent our way out. And I think one of the great virtues of having this tariff in place is it provides a framework of greater confidence to do the work here in the United States to develop a viable alternative fuels industry. We have the biomass growing on the North American continent that could provide us, in theory, up to 60 to 80 billion gallons a year. So that would be not a complete solution, but we could get 40%, 50% of our annual fuels requirement from surplus biomass that grows here in North America.
Well, let's drill that issue a little bit further. You believe that from biomass available, feedstocks available, we could replace almost half of our gasoline consumption?
Well, I'm citing to a study that was done first at Oak Ridge National Laboratory about 3 or 4 years ago that found there's about 1.3 billion gallons, 1.3 billion tons of biomass that could be harvested outside of the food chain and would not materially impact food prices. There have been some adjustments to that, but basically that order of magnitude, if you've got 1 billion tons, and if you can get 80 to 90 gallons per ton of biomass, which is what we are projecting with our process, that gets you to 80 or 90 billion gallons per year on a sustainable, recurring basis.
Is that intercutting the forests, or
that's all the land? That's all the land.
Where does it come from?
Well, that would be from slash and harvest from timber harvest operations. That would be surplus biomass from, say, corn stover, from the what's left over from corn production, from sugar cane. It could be switchgrass. So there are a lot of different. I could certainly get you a copy of this study. There's a great diversity of sources, and really the sources are different in different parts of the country. So you have different types of timber in the Pacific Northwest, and grasses on the Gulf Coast, and hardwoods in the northern tier of the Great Lakes.
What does that do to the chemical balance of the environment? I mean, it's stuff that would rot slowly or quickly on the ground and now be
more greenhouse gases.
Yeah, no, there's a limit. You can't strip the soil you can't strip the land year after year of this growth. So there's a limit as to how much you can take and have the natural processes replenish the fertility of the earth. We need to be concerned about carbon balance and how much carbon we're binding up in the soil. One of the great reasons for looking at switchgrass is that you plant it, it sinks roots, the roots build up carbon as they decay. You get carbon replenishment in the soil. If we do this right, we can get more carbon back in the soil and actually sequester a great deal of carbon back in our soil.